Hi, let me explain the next topic, that is topic number 4. Topic number 4, 4.4, that is magnetic field due to a long straight current carrying conductor. Magnetic field due to a magnetic field due to a straight long straight current carrying conductor. Alright, so first of all let us have the diagram for this. So this is a finite long current carrying conductor. Let me name this as RS. Okay, so from here at a distance of small letter a, let me have a point P. So if I am having a small segment of length, say dl here, and let me mark this distance as, say, small letter r, and let this angle be phi. Okay, so this angle is 90 degree. So due to this small segment, like let this be q p pq, so this is dl length, and let this point be o. Okay, so here we are going to calculate the magnetic field due to this one. So current is flowing from R to S, so the magnetic field at this particular point is supposed to be across. We have already explained about this one. Yep. Okay, so according to Biot-Savart law, the magnetic field, if I mark this as dB, so the magnetic field it must be dB equals mu naught by 4 pi, okay, I dl sine theta by r square. So here, as per this equation, theta is missing, so let this angle be theta. Okay, so this angle is theta. So the magnetic field dB is mu naught by 4 pi I dl sine theta by r square. So if we need to calculate the magnetic field at point, this particular point, so what we should name, P is there, Q, R, S, O, this point B. T, let this be T. So at point T, the magnetic field due to this entire wire, it has to, for that we can divide this wire into small segments. Okay, then we need to, so if we divide this small wire into the small segments, and after that we can take the vector sum of magnetic field due to this one plus this one plus this one, etc., up to this one, then we will get the resultant magnetic field B. Okay, so B is going to be basically integral of dB, isn't it? Thing is that from integration from where to where, the limit, that's something very important. So if we come over here, see, before that, in this particular expression, this particular expression, in this one, we need to check which all are the constants and which all are the variables. So here this is a constant, isn't it? This one is a constant, and this is a variable. Here this one is a variable, this one is also a variable. Variable in the sense, if I come over here to this one, this L vector, R vector, and theta, these are going to have different value while moving towards this one also, isn't it? These are going to have different values. So I am having three variables. This one is a variable, as I mentioned, this one is variable, and this one is also a variable. So the question arises, like in as a function of which variable I am going to integrate this one. Okay, so I'm going to ignore all the three, but I prefer the variable to be 5 for that. So for that, I need to change this dl term in terms of phi. I need to change this theta in terms of phi, and I need to change this r term in terms of phi. And then later on, what happens is that this limit is going to be, let me mention it over here. See, if I join here between R and P, R and T is going to make an angle phi 1, and if I join it like this, it's going to make an angle phi 2 S, and T is going to make an angle phi 2. Okay, so to angle phi 1 and phi 2. So here the limits is going to be, as I told you here itself, we must have a limit. So the limit is going to be from minus phi 1 to plus phi 2. Okay, that's going to be the limit. Okay, so these variables are going to be get converted into in terms of phi basically. So for that, I need the help of this triangle. This triangle. The triangle is a POT. So here this angle was phi, here this angle was theta, and let this length be L. Let this length be L. Okay, so here this length is L, here it is R, this distance is R, and here this is small letter A. So from this triangle you can see that I need more space. So it's very clear, L upon A, that is tan phi. Okay, so L equal to A times tan phi. Now L is function of phi, so dl by d phi means A times d by d phi of tan phi. That will give it as dl by d phi equals A times sec square phi. Okay, so there we can have it as dl. So finally L is getting converted in terms of phi. dl equals A times sec square phi into d phi. So we are done with dl's conversion. Coming to the second one, that is sin theta. Sin theta equals from the triangle POT. sine theta is a by r. Alright, at the same time a by r is cos phi as well. So I can write sine theta equal to cos phi, and from the relation a by r equal to cos phi, I am getting done with small letter r as well, so r is a by cos phi. So after the conversion, the revised form of magnetic field into the small segment dl is dB equal to mu naught by 4 pi I into, instead of dl I am going to have a times sec square phi into d phi, that is dl, and for sine phi I am going to have, for sine theta I am going to have cos phi, and for r square I am going to have a square upon cos square phi, it can be written as sec square phi. Okay, so here what happens is this sec square phi, this sec square phi and sec square phi will get cancel each other. This a and a square will go off. Finally I'm going to have dB equals mu naught by 4 pi I into cos phi d phi times a. So the net magnetic field B, that is the integral of minus phi 1 to phi 2 times dB, that we already know, isn't it? So that is equal to, the constants has to come out, that is mu naught by 4 pi, okay, mu naught by 4 pi I by a integral minus phi 1 to phi 2 cos phi into d phi. Fine. While moving ahead, we are going to have it as b equals, see, b equals mu naught by 4 pi, okay, I by a integral of cos phi d phi, that is sin phi between the limit minus phi 1 to phi 2. Alright, that is b equal mu naught by 4 pi I upon a into upper limit, that is sin of phi 2, minus lower limit, that is sin of minus phi 1. You know that sin of minus theta means minus sin theta, so here this will become b equals mu naught by 4 pi I upon a into sin of phi 2 minus of sin of phi 1, that will give the final expression as mu naught by 4 pi I by a into sin of phi 1 plus sin of phi 2. So that was magnetic field due to a finite current carrying wire, and here is your complete derivation. Alright,